I have come here to chew bubblegum and kick ass. And I'm all out of bubblegum.
No,
oh, I won't film you. I'll just film Bob.
Okay, cool. I'm just wondering, you know, like when you go up to the Arctic Circle and the sun never goes down, the sun never sets in the summertime.
Right.
What's the reasoning for that?
In which model? Well, either it's the same.
No, meaning like I've been up there.
So have I.
And okay, well,
yes.
So when you go up that far in the summertime, why does the sun never set? If you know the whole concept of Earth is at a 45-degree axis. You have seasons that differ between the different poles, and you have a sun that's consistently up in the summertime north of the Arctic Circle, and the opposite when you go down by Antarctica.
Right. Okay. Well. Okay. Here's the thing. In both the globe and the flat Earth model, the sun, the Earth. Well, in the globe, the Earth is supposedly at a 23.4 degree tilt. Flat Earth model, there is no tilt.
Okay.
Right. You've got the North Pole in the center, and you've got the sun circling around it. Okay. Now, as it goes through the seasons in the flat Earth model, it gets closer to the North Pole in the summertime. All right. And as it's basically above the Tropic of Cancer, which is the northernmost tropic. Okay. Right around the solstice, you can actually be in the Arctic Circle and, of course, see it 24 hours like you've seen, like I've seen. Now, the flip side of that is, in the flat Earth model, it is impossible for you to have a 24-hour sun in the Antarctic Circle. And in fact, when you go looking for legitimate footage in the Antarctic Circle, they will show the sun going around. They'll claim it's 24 hours, but if you watch the time very carefully on it, there's typically anywhere from an 8 to 10 hour just gap that just jumps right over the top of it. So there is no legitimate footage of a 24-hour sun in Antarctica, and we have been asking for that forever. Their excuse is the reason they don't post that is because of data restrictions from the South Pole, which again, of course, is nonsense. But every bit of it is shown with a 10-hour gap in it. Okay, so in the flat Earth model, there isn't. Now, in the heliocentric model, the ball Earth model, yes, it would demand that there is a 24-hour sun there, but there isn't. And that's one of the biggest contentions of flat Earthers.
So, because of the different seasons, the sun rotates at a larger axis, and so, like, Australia would have a longer sun period than Antarctica has no sun period. How do you explain, like, the dimensions of Antarctica, because it's been proven that they've been able to travel around in a circular way with less distance because it is smaller and it is centered.
How has it been proven? Nobody has ever navigated the Earth north-south. No one has ever done that. Ever. There's actually one person that has claimed to have done it, who is a relative of the Queen, also a Freemason.
Okay.
And when you look at the actual track, the course that was taken, they go down around New Zealand, and they kind of mess around down there, and they come back up, but they never actually circumnavigate the South Pole. Now, in the flat Earth model, Antarctica is all around us, right? So obviously, if you are trying to circumnavigate it, you're going to, with reference to north, you're always going to be turning in a circle. A lot of people don't understand that. They say, well, how can you go around the Earth when, you know, and it not be a ball? And the answer to that is quite simple. If you have a magnet in the center of the Earth, and you are using a compass to align yourself to north, right? When you go east or west, the further you go askew from it, your compass is always going to draw you back around to the north. So you're going to wind up going around that north pole.
Okay, well, how do you explain the magnetic shift? You know, when you have like magnetic azimuth and you have true north. When you have deviation, how do you explain that? Okay, because maps change throughout the entirety. Like working in aviation, you see runways change numbers, change different azimuths.
I've been a pilot for 35 years, so I know all about that. All right, so here's the deal. Yes, there is a magnetic field change that is changing. This, I'm sure, has a lot to do with the entire construct of the Earth. It's changing at a very, very low rate. And what you're talking about is magnetic declination, all right? So you basically say, okay, well, if north is pointing this way, or this way, and you've got like an 8-degree declination like here in Colorado, that means that really north is this way instead of this way. Now, that's only necessary on a ball earth model. In a flat earth model, it's not necessary at all. Because in the ball earth model, you have to constantly correct for an imaginary ball. But in the flat earth model, that's simply not necessary. And the other thing you also have to understand about compass navigation is that compasses always follow the magnetic flux lines of the earth. Okay?
So where was the magnetic flux lines of a flat Earth? Where would the magnetic flux
well,
lines
they start. They're just like any other magnet. Okay, it's always a toroidal field. Okay, so you have the centrifugal lines of the toroidal field, the donut, right, in the magnetic field, and then you have the centripetal, which are the lines that go down inside, or the hyperboloid, all right, through the center. So those lines, if you have a magnetic mountain, as is shown in the flat Earth model, and basically you have both your north and south pole at the center and the North Pole, except the South Pole is submerged down below the ground. So you still have that toroidal field that goes out, except it's expanded out along the flat plane. That's what's called the dielectric inertial plane, by the way, the center part of that magnetic field. So when you're navigating with a compass, if you can imagine these toroidal flux lines that are going out, and also the centripetal flux lines, anywhere that you are along any of those flux lines, that compass is going to align with it. Not always pointing at the North Pole, but wherever it is amidst the field itself.
So you're saying South will actually be submerged in the ground?
The South Pole is, well, that's one model. I'm beginning to think more and more that's it. A lot of people have said before that the South Pole is actually at the outside.
I mean, one of the big things is you talk about different models with the flat Earth method. You know,
right.
like, so there's no actual, like, model with it. I mean, we know that magnetic deviation is a real thing. We know that, you know, when you go north of the Arctic Circle, you get to talk about these different things, but if there's no true model, like, that's why I have a hard time.
Stereo speaker.
That's why I have a hard time just kind of understanding it, because if you have so many different concepts, how can you guys all agree on one situation?
Well, primarily, that's just it. I mean, nobody is agreeing on any one particular model, and it's for that very reason. I mean, we don't have the resources to be able to map the world, especially when there's an active deception against us at this point. And there really is. The thing that we've got going for us is we can prove every way but Sunday there is no curvature to the Earth. Gyroscopes prove this unequivocally. I've been a pilot for 35 years. You know, we have gyroscopic instruments in the plane. If we were truly going over a curvature, there would be drift in the gyroscope, and there is none. There never has been, and there never will be any. One of the biggest proofs that we're about to come forward with is with what's called a ring laser gyroscope, because supposedly Foucault 170 years ago did this gyroscope test, right, where there was precession, you know, as the Earth rotated. Okay, nobody has ever been able to replicate that experiment today. I've got a 21st century, you know, precision gyroscope. I can detect absolutely no precession whatsoever with my gyroscope. Well, the ball Earth rebuttal to that is simply the reason for that is because the bearings are too restrictive on the device itself. Great. That may be true, but we've proven that it isn't by putting it on another mechanism that rotates at 15 degrees per hour. So we know that's not true.
Test that, like, so you do go into space and really be able and have the free motion.